This screencast is about solving linear inequalities, which is very similar to solving linear equations with one major difference.
Let's start by comparing the process of solving equations with that of solving inequalities. They're basically the same in almost every area. If we're going to use the addition and subtraction properties of equality in equations, there are addition and subtraction properties for inequalities as well. If we add or subtract something to an inequality, it does not change the nature of the inequality, just as it does not change the nature of an equation. Similarly, multiplication and division of positive numbers does not change the inequality situation either, just like it doesn't with solving equations. Where there is a major difference is if we are multiplying or dividing both sides of the inequality by a negative number, that actually changes the direction of the inequality. So if it was a greater than, or a greater than and or equal to, it then becomes a less than or a less than equal to. The other difference winds up with the answers, and that is the solution. Typically in an equation, you're going to get one unique solution, typically, for linear equations. For a linear inequality, you will often get a set of solutions. For example, x greater than or equal to 3 means that any number that is greater than 3 or the number 3 itself would satisfy that inequality. So let's look at an example. We want to solve the inequality 4y minus 3 less than 5y plus 2. And we're going to graph the solution set on a number line. So we're going to take this inequality and we're going to treat it really just like an equation, because remember, those properties of inequality are very similar, with that one exception, to the properties of equality. So 4y minus 3 less than 5y plus 2. First thing we're going to do is try and group those y's together. So we're going to use the subtraction property of inequality to subtract 4y from the left side, thereby getting rid of the 4y, and subtract 4y from the right side of the inequality. That cancels out the 4y's on the left, and we're left with negative 3 less than y plus 2. So again, our objective is to isolate the variable y. So we're going to use the subtraction property of inequality again and subtract that 2 from both sides. The 2's therefore cancel out, and we're left with negative 5 less than y. Now, typically, the way we think is the variable on the left side for these inequalities as we're stating them. So we're going to just change that and flip it around, which means that you do need to flip the direction of the inequality around. So instead of negative 5 less than y, you get y greater than negative 5. Both statements are true. It's just this is typically the way you're going to see it and speak it. So now we're going to graph this on a number line. Since there's a greater than, we're going to look at all the numbers that are on the right side of the number line of negative 5, but not including negative 5. Now, if this was y greater than or equal to negative 5, which it's not, then we would also include negative 5, but in this case we don't. So let's see what that looks like. We're going to put an open circle on negative 5. Open circle meaning that negative 5 is not part of the solution set. And then we are going to, you need to shade everything to the right of negative 5 with a solid line, with it terminating with an arrow, because all the numbers to the right of negative 5, including the ones that aren't visible on this number line, are also part of the solution set. In fact, it goes all the way to positive infinity. Let's look at an example that involves that difference, that exception. So if we have the inequality 12 greater than or equal to negative 0.3p, and we want to graph the solution on a number line, we see that we have a multiplication here. Negative 0.3 is multiplied by p. We want to get rid of that negative 0.3, so we are going to use the division property of inequality by dividing both sides by negative 0.3, which will cancel that out because anything divided by itself is 1. Now, because multiplication and division by negative numbers requires you to change the direction of the inequality. Instead of a greater than or equal to, it becomes a less than or equal to. 12 divided by negative 0.3 is negative 40. And of course, the p is now alone because negative 0.3 divided by itself becomes positive 1. So now we have negative 40 less than or equal to p, but we're going to go ahead and flip that around just so it looks a little better. So p greater than or equal to negative 40. Let's look at that on the number line. So our solution set is all p's that are greater than or equal to negative 40. Negative 40 is part of the solution. We're going to use that closed circle now, starting at negative 40, and it is all the numbers greater than or to the right of negative 40 as well, all the way up to positive infinity. You know, the direction of that inequality should match the direction that your solution is going. To the right means greater than numbers. To the left means numbers that are less than. And then, of course, also negative 40 is part of the solution. Let's look at a more complex example. Negative x greater than x minus 7 divided by 2. And we want to graph this solution on a number line as well. So we've got to somehow get those x's together and isolate the x. First thing we want to do, though, is get rid of that 2, because the x minus 7 is being divided by 2. So we're going to use the multiplication property of inequality to multiply both sides by 2. Now, since we're multiplying by a positive number, that does not change the direction of the inequality. Remember, it's only when we're multiplying or dividing by a negative number. So multiplying both sides by 2 yields negative 2x, because negative x times 2 is negative 2x. And then on the right-hand side, x minus 7 divided by 2 multiplied by 2 will cancel out the 2's. So we are left with this inequality. Again, the direction of the inequality has not changed because we multiplied by 2. Next thing we want to do is move that x to the left-hand side. So we're going to subtract x from the right side and subtract x from the left side. So the subtraction property of inequality, or it's the same as adding a negative x, yields negative 3x, because negative x minus 2x is negative 3x. And on the right-hand side, we get x minus 7 minus x. The x's are going to cancel each other out, and we're left with negative 7. So negative 3x greater than negative 7. Our next step is going to be divide by negative 3. Division property of inequality will cause that negative 3 to cancel out on the left-hand side. However, now notice the direction of the inequality must change because we are dividing by a negative number. Negative 3x divided by negative 3, that's just x. The negative 3's cancel out. And negative 7 divided by negative 3 becomes positive 7 over 3. So our solution, x less than 7 over 3. The direction of the inequality has changed. Let's look at that solution on a number line. So the solution is all x's less than 7 divided by 3, or 7 over 3. So since we have a less than, 7 over 3 is not part of the solution. We're going to use that open circle. And the direction of the inequality is pointing to the left. We're looking at all numbers that are smaller than, or to the left on the number line, of 7 over 3. So we're going to have a solid ray heading towards the left, towards negative infinity. So any number less than 7 over 3 is part of this solution set. In this screencast, we looked at solving linear inequalities, which is very similar to solving linear equations, with the exception of multiplying or dividing by a negative number.